and the exploitation of least squares and minimum cut techniques on graphs to solve problems in MRI. By far my favorite application of mathematics and engineering has been during EE-168, a digital image processing class. For the Prino project, I implemented an expanding circular high-pass filter on an image's Fourier domain. By explaining the fact that the edges of the image are higher frequency components, where was I? By explaining filtering the image in this way stencils the image. By oscillating between different sizes of the filter, I created a Nightcrawler vanishing technique, which, along with other image processing tricks, including a squirrel Stanford's tree circular morph, has earned me the Algener Award for Best Electroengineering Undergraduate Project. I also wish to tackle a number of difficult questions while I'm at your university, many of which are engineering logic hybrid questions. For example, in dynamic logic, I learned that we can model sequential programs and represent ideas such as just happened, about to happen, and happened at time t. But how do we model parallel programs that bound the realm of electronic systems design, e.g. a program in Verilog? In particular, how do we design a logic system that expresses happen simultaneously at multiple instances of time? True, simultaneous events at a time can be expressed via a simple conjunction, but I want something much stronger than this. I want to express ideas such as certain programs occur simultaneously for all or eventually all times. Because of the any quantification over all time and the exist any quantification for eventually all, the idea would be difficult to express in a logic system that, say, has a modality for each time. My summer research project in optimizing MRI images given interference from a fat signal has also inspired me to ask another question. In this research, the goal was to estimate the correct fast field map matrix, given that each element had a number of possible values, phases. But there is a natural bijection from these types of matrices to model modal logic. We can associate each element to a world, each phase at that element to an atom at that world. Would it be possible to represent different criteria for an optimal field map, e.g. satisfying some smoothness function, as a set of axioms? And if so, what results can we derive under the lens of modal logic? However, all these questions are secondary to the research that currently occupies my time. In my final quarter at Stanford, I won the Mathematics Ceremony Commencement Award for proving algebraic completeness of Open01 null with NGP by designing a thick Cantor set coloring scheme. Yet I was only able to prove algebraic completeness for propositional logic and outside my thesis for modal logic. In the case of first order logic, Professor Mintz, my honors thesis advisor, alerted me that a counterexample can be found in Rasiowa's and Skirokovsky's The Mathematics of Metamathematics. However, Professor Mintz believes that we can redefine the algebraic semantics of first order logic such that there is still useful interpretation and that completeness holds. Thus, before I departed to Taiwan, I photocopied the entirety of the elusive Rasiowa and Skirokovsky texts, and ever since I arrived in Kaohsiung, I have been reading the first few parts. When I reach the latter half of the book, and finally see the algebraic completeness counterexample, I intend on examining the counterexample symptoms and diagnosing the problematic semantical definition, which I am certain is in the infinitary nature of the quantification interpretation. Otherwise, I intend on finding the fragment of first order logic that has complete with respect to algebra, Open01 mod null. Thank you for considering me for candidacy to your PhD program. Academia is where I belong, and returning to the universities would mean so much for me. And though I will continue my own research, and while severed from the academic community, I'm more likely to strive if I'm at the front lines working alongside my peers. Thank you. So that was my statement of purpose. It's interesting. The first half was completely personal, and the second half was completely impersonal and about my research and experience. Only the first half was there at the beginning when I first wrote this. But when you apply to graduate school, many of the schools, they don't ask for your resume. So I had to talk about my own, and personal statements, you have to talk, it's actually explicitly written there that you should talk about solely your research experience. But you know, and people have told me, half the people have told me, get rid of the second half, and the other half have told me, get rid of the first half. But you know what? I'm not just, well, it's like a yin and yang. I can't just leave out my personal half, because that's what the reason I do this. and I cannot leave out the second part because that's what I've done, and I've worked hard, and I hope one college would see this and say, damn Philip, you worked hard and you deserve to get in. Anyways, so thank you very much. I will try to release more videos because I promised. Now this is my 100 video and I'm happy that I finally got it out. Anyways, thank you very much, and Math Dojo guys, thank you for waiting. Hopefully I can continue working with you guys. Sorry for 2 months of disappearing. And maybe I'll post some of my opus that I'm writing. Okay, thank you, and thank you for watching this channel. Math Ninja out.